This, we're so close on. I was gonna sleep, like I was gonna actually sleep. Yeah, and this sleep effect is so rapid. Like really, really careful. I was gonna go to sleep. That was so smooth. Let's do work, energy, and power today. Do work, energy, and power. How are you today? Oh my god. Work, energy, and power. Work, energy, and power. Yep, that's what I. Wait, this is not the one. This is not the one. All this and really bad and give us what we put this up and do. Let's go. We're not gonna give it. I'm not gonna put that on. We're gonna do it. We're gonna do it. We're gonna pick it down. We're gonna have the energy tools. Let's do it. Let's do it. Let's talk. Why am I in underline? This is not the thing to say. Yes. The main thing. Let's start off. Let's look in now. This was open. Oh my god. Oh, okay. Okay, never mind. Reverse I for what is this? Amount of force applied on an object exerted on the object. Such that on the object such that it gets displaced called as when it's to be affected. Okay, alright, we did this. 1 joule is equal to 10 raised to 7 joule. I think that we got the idea about this one, right? So, yes, how's everything going? How are you? How are you doing? Bro, do you mind subbing to my channel? You're gonna be my 60th subscriber, that's right. If you do it, I'm gonna be really, really grateful. Please, if you don't want to do it, it's fine. It's upon you. Please do it. You can become my 60th subscriber. Yeah, actually. I'm gonna do a lot of stuff. Each and every sub looks like a million subs for me. Please. I'm really, really, I'll be really grateful for the person. Like, let's do that. This can go so. That's driven by constant force. We have a object on the ground and it does not look like sport, but it's fine. I mean, if he does not, so it's fine. I'm not gonna force him at all. And I don't mind subbing to my channel. I don't want to post for him. I should not do that actually, because it's very very shouldn't make him like this. Let's don't let's not do that. Need to respect vector is going to be f cos theta. This is going to be f sin theta. So W is equal to F vector dot S vector. So since this is a dot product, I can say that the commutative property gets applied. Not only that, but the dot product always gives us a guys. Oh my god, how are you doing? Hi, hi, how are you doing? Guys, do you mind subscribing to my channel? If anyone does it, they will become state subscriber of my channel. I will be really love it. If you want to, you can do it. Depends upon you. So yes, you can. You don't have any possibility of thinking that you can do it or not. Depends upon you. I don't want to force you again. That's all. Do you mind doing it? I was thinking of asking this question. Let's see, guys, before we do it. Let's see. Hi. How are you guys? How are you? If you don't know what I'm studying on this, student, energy and power physics, that's fun. Another concept projects kind of force them, of course. Really wants to force them. I don't want to force them. Yeah. Idea, hi. How are you? How are you guys doing? You guys, do you mind chatting out so that I can actually give you a shout out? Yeah, right down. Why, there's one moment actually, I still remember. How are you doing? How are you guys doing, guys? Uh, hi, Saima Ija. How are you doing? Fine, I'm fine. Hi, how are you, Saima Ijaz? How are you doing? Shout out to Saima Ijaz. Do you mind if you can sub to my channel? You can become a 16th subscriber. Oh yeah, I'm studying physics. I'm studying physics. Work, energy, and power. That chapter. If you actually sub to my channel, you'll become my 16th subscriber. That's what I can say. Depends upon you. Hi, by the way. How are you doing? Oh, this is gonna be fun actually, not gonna lie. It's gonna be really mm, let's do it, okay? I'll give a shout out to Sam Jones. How are you doing, bro? Mm, if any, I'm studying physics, and in physics, I'm studying the work energy problem. Well, by the way, do you mind subscribing to my channel because we're gonna hit 60 subscribers. And if we do that, it's because of mainly you and all of the viewers who have been watching me since do you mind doing that? It will be a really huge honor for me. Depends upon you. I'm gonna actually do just for the nature of work. Nature of work can be divided in three types. So what are the nature of work? The nature of work is basically positive, negative, and how do we know that these work done can be positive, negative, and zero? So first of all, in order to know that they are work done to be positive, we need to know that the angle between the angle between the work done for force and displacement vector should be an angle. Should be less than 90. Should be less than 90 degrees. And if it is less than 90 degrees, then this means that there is this work done is positive. For negative work done, the angle between these two, that is the force vector and the displacement vector, force vector and displacement vector is is basically should be less than should be more than 90, or you can say about two times more than 90. How are you doing there, bro? How are you doing? Looks like no one doing that. Uh, that's not okay. No one has to use my phone with jobs. Okay. The angle, the force vector acting on the body, the force is acting on the body, then but the body doesn't displace, but does not displace. It doesn't displace. So uh, this is gonna be oh hi bro, how are you doing? Displace. So you can say that, or you can say that the work done can be zero because the force vector is perpendicular to the position or the distance position vector or the distance vector, the position vector, and that's how we actually define. Okay, so in order to actually have an idea based on this, we have classified your positive work done. Let's do that. A positive work done is basically the angle between the force vector and the displacement and acute. For the negative one, the angle between the position or the displacement and the force vector we are not using. And the angle. Oh wait. Elisa Yolanda Della Gomba. Oh, Elisa. Hi. Shout out to Elisa Yolanda Della. Gamba. That's a pretty long name, by the way. I knew it. Do you mind subscribing to my channel? I don't want to force, but do it $2 because you're gonna be my Steve subscriber. Yeah, okay, let's go then left. I. Why does it say game over though? What? I don't know who's that. That happens. Then we have another one that is basically that and if we talk about work, other than the work part, we have to write examples. So example, I can say that a person is pushing a box, pushing a box. Why? That is that is the amount of easiness. That is the amount of easiness that can actually see. A person is pushing a box. That is basically what's the word done. Now, what is your negative word done? What is the negative word done? Wait a minute, guys. Hi, 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 hi. How are you doing? Stop spamming hi. Please stop spamming it. I actually don't do that. But yes, shout out to Bill Poster. Shout out to her. Can you stop spamming? Yo, okay, never mind. Anyways, what we need to have an idea we so what I was talking about basically here is that the person is pushing a box. Okay, that one was the example. Another example we can say for the negative work done. Okay, what would be the negative work done? What could be the example for the negative work? In order to actually answer that, uh, you can actually look at one kind of example. Okay, now what could be the example for this one? What do you think? What would be the example for? If I actually take this course, suppose I have, how to explain this? This is an interesting one actually. Like this circular motion, like the circular motion will give zero work done. The reason why zero work done was in zero work done, what basically happens is that when a planet revolves around the sun, what happens is that the planet is moving in a direction perpendicular to the tension force. Not the tension, sorry, my bad, the gravitational, and therefore it becomes perpendicular. And due to the perpendicular force, this means that the work done is you've got, you've got. I think you know what I am talking about. So this is the one part you should understand about. Okay, this is the one thing you should understand. Now another part we need to have an idea on how we're actually going to write the examples. Example will be suppose that suppose a planet revolves around the sun, revolves around the sun. There's zero work done there. Then it will, you know what the porter who actually carries luggages to his head? That's the Indian Railways, not a. I don't think so. They're present, but yes. And that's how we actually get the main idea, main thinking of it. That's how we have an idea of that. So, thinking around the sun, and that's the idea of this one. So, the planet is basically revolving around. Okay, they're revolving around the sun, and their tangential direction is basically perpendicular to the gravitational. So, since the r vector and force vector are basically perpendicular, can we say that Fs cos 90 is gonna be zero? How? How is it zero? Because cos 90 is gonna be zero, and that zero gets multiplied with Fs. Because of F vector dot S vector gives Fs cos 90, that is basically giving you zero. That's how we actually mathematically can mathematically say that our our work ouch, our working can be zero. Okay? Oh, sorry. Stop triggering for noise. It's fine. Let's just work in for a moment. Alright? Anyways, okay? Anyways, W is basically W is working. W is equal to F vector dot ds vector. Okay? F vector dot ds vector. That's the thing we need to have out. Now, how do we explain this? This thing is basically gonna be actually written as this. Why am I saying this? First of all, understand. This is the work done by a variable force, meaning that the force will vary at any certain second, at any certain time. You will see that force is varies by a variable force. Yeah, I'm kind of short right there. Ouch, ouch, ouch. I swear I'm choking. No, wait. Let's not give up, guys. Okay, let's not give up. Um, the thing is that we need to first of all get an idea based on what we're gonna do. That is W is equal to integral of what? If A is B, and that's where we can say F vector dot ds vector. Yes, F vector dot ds vector, and that's how we actually operate this. Anyways, what I can give you an answer about that is that there's basically this here. This is A, this is B, this is a small distance PQ. Okay, there is small distance, very small distance. That we'll take it as ds. We'll take it as ds vector because it's small distance. Small distance. Okay, you got it? You got it, guys? So this means that dw is equal to basically I can say that f dot ds vector. Yep, can we say that? Yes, you can say that. Of course. Say that. Now, work that is basically the integral of f vector dot ds. That's what idea. This thing actually there is a limit of it because if you do not put limits, we'll also get constant after we integrate the formula or the expression. So we will put limits that is S A. So W is equal to the upper limit will be SD and the lower limit will be SA. Yes, that's ideally we can have on. And this is the way we can actually get the main context, the main idea for it. So that's the main thing you should go through so that you can actually have an idea of it. So W is basically equal to the F with I took this one. I got the idea of it. We're gonna actually check, okay? Just check. So W I can write it as S or upper is gonna be F vector dot ds. And I have the capability of basically recording. So what do I get? What I have to check for, what I will be thinking of, what is basically the we need to have an idea of this product. So once we actually do the integration, we will get our final value. Let me first talk about that. So let's talk about this the variables first, our force here, and then we have our then we read it. Just this is like that. This is gonna be a variable. This is gonna be like going to a head. It's gonna vary. Oh, wait a minute, guys. Is it crashed out? Oh, wait a minute. My cam got crashed. Let me repair my. Wait a minute. I thought my cam wasn't crashed out. Oh, damn. This is not good. My cam. Right. Here you go. Here it is. Cam is working. Sound comfortable. Alright. Let's see, take the and get the idea of what we're gonna do. Distance and as was vector, we're gonna get the now vector. Anyways, what we need to have an idea is basically we are this one and this one with this one. Of course, I'm not gonna listen to it because I know that this is going to be not about very much useful stuff. Anyways, I'm gonna turn this one down. I'm gonna put this back here, and we will have this one small portion cut off, and that is gonna be our data. This is gonna be the first small part that we have, and the W is equal to of S and this is S or DS, and that's how we're gonna figure it out. Alright, what is conservative first? That's what we find. What is a conservative? What is it mean by conservative? So first of all, in order to understand this, we need to know the main 2 points. The first point of the conservative, what does it explain? The first point of the conservative explains that the total work done, okay, the total work done in a closed path, okay, the total work done in a closed path is always, alright, the total work done in a closed path will always be equal to zero. That's a fact. It will always be in a closed path will always be equal to zero. And that is the main thing. That is the main idea we should have based on that. So yes. Alright, okay, alright. Checking my mic, that's it. Did you see I don't know who's watching me, but if you would like to sub my channel, because we're gonna hit almost 60 subs, and if you do that, I'll be really grateful. Because each and every sub is like, each and every subscriber is like, basically 1 million subscribers. So if you do it, I'll be really grateful. I can even give you a shout out if you want to. Depends upon you. Anyways, I'll go back, I'll go study. And if you're subscribed, then it's fine, that's great. Okay. Math addition. Don't worry, this game is completely safe and designed to test only your numbers knowledge, not your strength. In the game, participants must go through different levels where only players who, who know about prime numbers, composite numbers, factors, and multiples can move forward. Identify the non-conservative force. The non-conservative force is basically the total work done in a closed path. Okay, it is not always not always the total work done. The closed path will never be. Can you say that? A lot of people doesn't mean that it actually say that. It will not be equal to zero. Equal to zero. It closed path. Okay? That's the main thing actually. That is the idea of welfare for nature. The conservative force also has another part. What does it mean? That it depends upon final uh, not on the what about final and initial? Basically, what I'm talking about here is force. The thing is that there are final the final items for that. So yeah, the final it depends upon the final and it depends upon the final and initial one. All right, and there we can say that the final, final and initial point, okay? Where we basically get the idea of what we basically are getting. The idea that it does not depend upon the path, it does not depend upon the path, yes, it doesn't depend upon the path, does not at all, okay? Doesn't depend upon the path. That's the main focus, that's the main idea in order to actually move on and get to the most, more main concepts. Another fact is that we need to write examples too. Like for examples, I can give for conservative gravity, of course. Then I can give electrostatic force, electrostatic force between two charges, electrostatic between two charges, and that's given here. And then what else? What else do we need? The non-conservative. What's the example for that? It depends upon the path, and does not depend upon, and depend doesn't depend upon what doesn't depend upon what does not depend upon the final and initial points. Okay, wait, there is a no doubt I think I will point out I'm gonna make you wait here. Positions, okay. Positions, initial points. And these final and initial points, I was like, there was someone mistake I made overall. And I was like confused very well. I was like checking about that, like how much will be that and how much will be not. So that's the main concept I was thinking about. The main concept I was thinking about. And let's get talk about it. Let's get put this forward and let's put that thing later. Okay. Alright, okay. Very good. So first of all, is that the final feature point. So, as I was actually explaining about the conservative and non-conservative forces, we also discussed about this. Now let's discuss about the examples. So what is the example I can discuss about this one? What could be the examples I could talk? The basic example I was giving for this one is basically what? What? We know that, right? So in order first of all get the answer for this one, I'm going to first cover that part here. The example, I'll give frictional force. Then after frictional force, I can give another example that is um, buoyant or resistance or any kind of force. Now we have to discuss about energy. Energy. The daily thing that you feel like I need some energy to get that thing to be done. I need that energy in order to do that activity. Well, in physics, the energy are actually basically not only about doing activities. Well, yeah, of course, this is based on activities. We learned this in biology, of course, but this energy that you're talking about is going to be more scientific, meaning that the energy we're going to talk about is not only going to be based on energy. That is mainly based on what? Mechanical energy. Mechanical energy. Part of mechanical energy. So what is the mechanical energy given as? Mechanical energy is basically the sum of what? It is the sum of kinetic energy and potential energy. Sum of EK and EP, that is kinetic energy and potential energy. That's the main stuff. But this does not mean that this is the main thing we need to write down, right? So, what should we exactly mention here? In energy, it is basically, you can say that it is the capacity of the work done is capacity of the work done. I think yeah, that is the main thing we need to know. That it is the capacity of the work where we actually spend our work done. That's how we need to explain that work done, right? So it's related to our work, and even there's a theory known as work energy theorem. That is basically given by James Prescott Jones. Oh shoot! Looks like my live stream is gonna end. I have to end right as fast as possible. Guys, bye guys. Bye.